Good afternoon, ladies and gentlemen. My name is Alexo Pico. I'm the Managing Director of the Circle Group, and you are tuned to one of the events of Connecting EU Insights. This afternoon, we have a very interesting double interview. It's also a kind of format in which we are going to talk about wind propulsion in maritime transport. It is a very key topic and a hot topic, especially thinking that in the times we are living, we are always looking to sustainability and decarbonization, and this is for sure one of the elements that could contribute to. We have the pleasure to have with us today Gavin Allwright, Secretary International Wind Ship Association Secretary General, and the founder of and CIO of Smart Green Shipping Alliance, Diane Gilpin. So good afternoon, Gavin, and good afternoon, Diane. Both you are based in UK, so it's still a little bit morning maybe, but thanks for coming. And before going to the direct the double interview, what I'm going to frame a little bit, I'm going to do is to frame a little bit the wind propulsion subject, okay, topic, using a couple of slides that kindly the International Wind Ship Association sent to me. I think you know what we are talking about. We are going to talk about the fact that wind is of course a renewable energy and could be effectively used to move and to support the movement of vessels. And the industry is growing a lot, really a lot, with a lot of potential. What we are talking about is just to highlight a couple of things. We are talking about systems that could, with retrofitting, have from 5 to 20% savings, but even up to 30. It is available today. That is important to say. It's not something that is going to come. We have already in the industry a robust pipeline of projects coming, as you will see. In terms of market and forecast, this is what is. Sorry, I made a mistake in moving here. Sorry, let me just come back to this. And we have no, I cannot move this. Sorry. We have 12 to 14 ocean-going vessels already with wind assist systems installed by the end of 2020, meaning now, and 20 small sail cargo and cruise vessels in operation already. And in terms of pipeline, as I was saying before, we have an existing pipeline of 47 retrofit and new build vessels, vessel C trialing and commercial operation, and meaning plus more than 30 smaller vessels by the end of 2022. And as you could see from this research of a couple of years ago, that was saying that if the potential wind propulsion reach marketability in 2020, that is now, and you see that there is this marketability, the max market potential for bulk carriers, tankers, and container vessels is estimated to add up to around 3,700 to 10,700 installed systems until 2030. That's a big market anyhow. Just as a last point, you see that here in this slide, highlighted in green, already available showcases, let me say. The Silent Seas range, this is already available vessel, such as the rotor sail installation that is part of a EU Interreg project called WASP for Scandilines. And you see that there are a lot of installations and new build order for 2021 and 2022. But of course, there are a lot of let's say questions around this. There are a number of questions coming from the industry, coming from of course, the ship owners, ship operators, and that it's going to be, in a way, very useful to discuss with top-level experts in this field. So thanks again, Gavin and Diane. I'm going to raise a number of questions that we prepared. You feel free to answer as you wish in terms of the combination of the two. And we'll start with the first one, that is about safety. Okay, so one concern could be safety, and specifically about risk management. Which are the solutions in terms of this possible safety concern?
So thank you, Alexio. Thank you very much for inviting me and also Gavin, who he can speak for himself, to be part of this. I thought I'd jump in on safety because we completed last year a feasibility analysis working with partners from across the shipping ecosystem, from cargo owners, ship owners, operators, Class, Lloyd's Register, marine engineers. And at the very, very heart of the conversations that kicked off our collaborative project was safety. This is not something that we're ever going to compromise. We are all completely aware of the fact that these vessels need to be safe. So the design brief put safety at the very heart of the solution, and what we were able to do throughout the feasibility study was to work directly with the ship owners, with the crews, with the masters of vessels, with the ports that the vessels would be docking in, to understand all of the challenges that the industry faces now and what additional challenges there might be if we added wind devices. And so I think it's really important to recognise that this isn't something that we as technology developers are doing on a whim. This is something that is embedded into the way that the shipping industry works today. And what we're doing is working with the absolute necessity to reduce emissions and to figure out how we do that by working across the entire system and then going through all of the safety analysis programs that would be required from any new vessel that was going to market. So I know people concern themselves about safety, and we do that too. And so we have not yet received any pushback on the technology that we've been designing, because we have designed it with safety at the heart of it. Gavin, do you have anything
Yeah, sure. I'll just chime in and sort of take that out a little bit wider. Yeah, and I'll reiterate what Diane said. Thank you very much, Alexio and Circle, for inviting me to come and talk, and inviting Diane. Yeah, this multi-stakeholder approach that Diane's project has adopted, yeah, that it's been absolutely critical for the development of these cutting-edge technologies. And as Di rightly points out, you know, safety first is the mantra across the board with the development of these technologies. And I just wanted to expand that in a industry basis, is that we now have publicly available, and some that are not public but are there, classification society guidelines for all wind propulsion systems, whether those be a wind assist or increasingly they're looking at primary wind. That's ABS, LR, DMVGL, Class NK, and BV is just updating those, and you know, we're obviously contributing there as well. So this is a maturing, not quite mature yet, but maturing technology segment, which is fully backed by the classification societies.
Thanks. Let's move to another topic, that is, what about the crew? Crew, in principle, should be trained and capable to manage this wind propulsion system. There are specific steps to be taken, I guess. Which are those steps?
Well, I'll speak in general to this, and you know, Diane and her project have looked more specifically into some of these aspects. But in general, there is a perception that wind propulsion is a step backwards into the 19th century, where we had heavy rigging systems, fairly large crew, climbing up masts to deploy the wind propulsion systems. What we're really talking, and there are still some traditional sailing vessels and sail cargo vessels that do have that approach, and there is quite a sophisticated training sequence and process that you need to go through. But the systems that we're talking about here are applicable to large vessels. They are they are all automated systems. So these are systems that will deploy and retract under the direction of the captain or whichever technical officer is operating that system. They're integrated into the energy management systems, increasingly so. And so actually that automation leads to a much lighter footprint in crew training, as it were. Of course, they need to be aware of the systems, they need to be able to maintain the systems, but we do also have, for example, distance monitoring of the systems is increasingly being adopted by some of our members, where onshore you can actually monitor the performance of the wind propulsion system, and you can be calling up the captain or the technical department and saying, hey, there's an issue with one of the bearings, you need to power that down at the moment. What I would add to that, and then I'll allow Diane to chime in, but we've also got integration into weather routing systems. If you want to optimize the deployment of your wind propulsion system, then, for example, the captain and other crew members would need to be changing their perspective and having some training about how can you get the best out of these systems. Now, that is a slightly different issue, not the operation of the systems, but the optimal operation of the systems. But even there, we can do weather routing, we can have weather stations on board. Quite a bit of that will be automated as well. But Diane, would you like to chime in with anything additional there?
Yeah, thank you. I mean, that was a great introduction. We have a very similar experience. Sometimes I've presented the visual of our ships, and people have gone, "Oh, the crew won't get enough vegetables." And you're kind of going, "Well, why would that be?" And it's because the perception the projection that we put onto the visual image of a ship with wings or with sails is that we're going back into the 19th century, and the world will be short of limes, so everybody will have a vitamin C shortage on board. And of course, what we're doing is retrofitting an existing ship with fuel-saving devices that allow it to operate in a 21st century logistics system. And it's not that difficult, but there is this kind of, because we've got this deep heritage with wind, 8,000 years of moving cargo with wind, we kind of automatically see it and go back in time. And that, I think, if we could overcome that projection, then what we would be able to do is to see the potential. I mean, we work, we'll talk a bit more about this later, with the European Space Agency, and there are lots of satellites in space, and some of them are manned, and they are manageable, and we can manage a ship at sea using this sort of 21st century technology. So the wing sails that we've designed, the fast rigs, are automated, but they're also intelligent. They will work on their own. They're fitted with sensors that can interpret the direction of the wind and the speed of the wind that's coming at the devices at any one time, and they will know that they have to retract if that's what's required, if the speed's getting too much, or the direction is coming straight onto the vessel, and that the rigs are causing a windage, so they're slowing down the overall ship. So that this is a really intelligent use of 21st century technology. It's born out of yacht racing and America's Cup technology and leisure yachting. So there's a huge amount of intelligent automation going into these systems. That said, the crew do need to know what's going on with them and how do they work. And we would be using so during the design process, we, as I said earlier, consulted with the crew and the captain of ships that belong to Ultrabulk, who we partnered with on the project. But we are also working with an organisation called Immersive Story Lab, who can develop systems in a virtual world, so we can train people without them having to leave their offices or their homes, by immersing them into a virtual simulated world and teach them, which is exactly the way that airline pilots are trained. So there's a myriad of technical solutions. The challenge is identifying the problems and solving those problems in the right order. And so I think with automation, I think with satellite support, and with an ongoing maintenance program that's described by Gavin just now, we as technology developers are thinking about all of those things because the market is pushing us to do that. And if you push clever people in the right direction, they'll come up with good answers.
Very comprehensive answers for coming from both. Thanks. Another perception in the industry is that using wind propulsion, you have some limitations in terms of cargo capacity or handling. Is this really true?
Yeah, this is me. Am I on? Yeah. Yes. So exactly that, Alexio. The perception is that you won't be able to get under bridges and you won't be able to get the cargo on and off. And so I would say that it's relatively easy to design a ship with wings or with any sort of wind, so long as it doesn't have to do any work. But once you need to take it into port and you need the crew and the port side authorities to be able to handle it, then you need to do some more smart thinking, which is why we have designed our wing sails to be retractable, and so they present very little additional obstacle to an existing ship. So the ships that they're retrofitted on would have the capacity to deploy the wing sails to harness the wind when it was appropriate to do so, and the capacity to retract and get out of the way so that the vessel can operate in exactly the same way as it would if it didn't have wings. And that, that's the biggest challenge to putting wind on ships, is how do you make it work in a modern logistics system?
Yeah, if I can just add to that, across the whole of the International Windship Association, the technology providers have all been grappling with this in various different ways. Some are retractable systems, others are collapsible, so we have actually collapsing down inside or breaking up and coming down as a concertina. There are also systems that can move. So there's a rotor ship that's in operation at the moment from Anemoy Marine Technologies, which has movable rotors. So you can actually move the rotors out of the way when you are loading and unloading, and equally you can actually move them around the vessel to help optimize those. One other aspect that I just wanted to mention was also that there's an interesting development or potential for modular systems. So we've seen a couple of projects that are looking at containerizing smaller systems, but this is still in its infancy, and I think that could lead to some very interesting developments within the business model as well, where if you're actually able to remove a system on some types of vessel, that could lead to a leasing or even a potential for a renting business model for wind propulsion systems. We're seeing this modular development happening in other areas as well. There's a very interesting design for cruise vessels in the fjords, which have containerized battery systems or other propulsion systems that slide into the side of the cruise vessel to create a zero emissions vessel for the fjords in the 2030s. So there's development, and I know that Diane has certainly been looking at this and looking at that whole, trying to upend and looking at the ship as an energy system, as opposed to a simple heavy industry capex piece of equipment. Right.
Thanks. This gives me the idea to come to a question that could be a little bit. So the modularity is also linked to the fact that you can, in a way, manage your the costs. What about the costs of these systems for what? And what about the return on investment? Because costs in themselves, okay, it means nothing, but it is the return on investment that is, you know, the main key KPI that is normally, you know, looked at.
Would you like me to handle that first, Di, and
then
you could sell a few units afterwards? Yeah. Okay. So yeah, obviously this is a big question that I'm asked pretty much on a daily basis. How much does it cost? I'm going to give two parts to that answer. The first one, I'll give you a generic answer, and then I'll give you maybe a couple of options that we should be looking at. The first one is, I can't give you examples of the cost, but I can give you a general number that starts to make sense for the deployment of these systems on a fairly good market level. So most of the ship owners that I talk to want around about a 3-year, you know, if it's under 3-year return on investment, that would be fantastic. 3-year in that area, then we have a commercial discussion. Pretty much the systems that are under development, that are standard systems, not with lots of bells and whistles on them, but standard systems, whether they're large and delivering large amounts of energy, or smaller systems delivering less energy but cheaper, you're looking at a fuel price that needs to be around the $550 to $600 mark per ton. Now, we were at that mark for MGO just before the COVID situation happened. In the periphery, you know, outside of the Rotterdam and Singapore rates, there are still some areas in the world where it's way above that for a ton of fuel. But I would say, averaged out over the last couple of years, we've been looking at it between a $450 and a $550 per ton for MGO. For HFO, standard HFO, of course, lower, but the ultra low sulfur fuels were creeping up, or the very low sulfur fuels were creeping up. This is without a carbon price on there, and we're already seeing moves towards that, especially in the EU, which would add $75 to $100 per ton of fuel today. So that starts to pushing the fuels up to make that work. The second part of the question is, should we be focused on ROIs, or should we actually be looking to move the heavy CapEx expenditure over to an OpEx expenditure? And that operational expenditure can be moved over, for example, by leasing the systems or creating a financial system, which are being developed for save as you say, or pay as you save. So paying for the system or paying for the loan by the guaranteed amount of fuel that you are saving per voyage, whatever it is. Those systems have the potential to really change the business model and turn it on its head. Di, I know you've done some extensive work in this field as well.
Just stolen my thunder.
Oh, sorry.
So, two things, like Gavin, slightly different. The first is that what the market currently has to deal with is the uncertainty of fuel price, and so there's a volatility that is inherent in using market-based commodity fuels. And what we need to be thinking about is primary renewable energy, like wind, is free at the point of use. And so if you're looking to capitalize your investment over 3 years, then that's a thinking that's based on that old model. What we're able to suggest is that you can put the technology on the ships, and we know to within a plus or minus of a fraction of a percent that you will save this much fuel on that route, and that's all predictable through big data from satellite, 30-40 year hindcast data, deep analysis methodology. We can insure against the risk of the wind not blowing. And so you start to decouple your asset from the volatility of the commodity fuel markets and have more fuel independence. And so as we start to think about that as the way to go forward, and we're thinking about what alternative fuels will be coming at us when we have to meet net zero, what we're doing is providing certainty on an element of your operational cost that you won't be able to get in the higher cost zero emission world that we're facing. But the other point that mirrors what Gavin was saying is that we've been talking to the ship owners a lot, and we would be proposing sale as service. So it's a fixed cost, and we provide the routing, the route optimization, operation and maintenance, and an insurance against the wind not blowing. So we provide a complete service. The ship owners then don't have to worry about all of the risk and who's taking what risk, and everybody gets more certainty into their business models.
If I could just add something, I mean, I think Di's covered that pretty comprehensively, and you know, I want to buy a few of her rigs already. So, but that's also one issue. You know, on a case-by-case basis or on a ship owner basis, you know, all of these aspects are really critically important. I just wanted to expand this a little bit into the strategy, the decarbonisation strategy for the industry as a whole, and frankly, at the moment, if we're looking at ROIs, we're looking at unit 1, we're looking at unit 10 of delivery. And the economies of scale that we will actually see in the deployment of, say, at unit 100, at unit 1000, and as you mentioned in the opening, at unit 10,000 by year 2030, we're going to see a dramatic decrease in the cost of delivery of these systems. That, coupled with a growth in the carbon taxation or levy, hopefully coming back into the industry ring-fenced as well, we're then going to be seeing substantial reductions in the cost as we move through this as well, which is natural.
That's true. That's an important element, Gavin, that you mentioned now. I totally agree. So we are living in an era in which sustainability and circular economy are definitely important. What about the reuse of materials? Is this feasible? Does it have any influence on the life cycle cost assessment? So what about these kind of things for wind propulsion?
I'm going to take this one because this is my one of my pet projects, really. There's a lot of thinking about operational emissions and not very much thinking about life cycle emissions. And we're living in a climate emergency, and we can't afford to be so picky about which elements of the problem we choose to solve. When we've set about designing our solutions, we embed them in the circular economy. So the materials that we use are 100% recyclable, and what that gives us in the circular economy model is the opportunity to build new business propositions out of it. So our very first collaborative meeting across the industry was held in Ellen MacArthur's sail loft in the Isle of Wight. And Ellen MacArthur, for those people who are not in the UK, is an absolute stalwart champion of the circular economy movement and has pioneered lots of hugely valuable research into the area. And so we are following on in that, and we want to template the ability to build a circular economy, manufacture without waste into the way that we build and market the wings, and then roll that out into a wider manufacturing and ship industry base. So it's a really, really massively complex project, but it is absolutely worth doing because it will change the way that we operate as a whole industry.
Yeah, I'd just like to make a very quick comment on that, because Di has certainly done a really good job of explaining that. I mean, this is an area where our customers are increasingly coming into play. They are looking, and I'm talking about the customers for the shipping industry. They are saying, we want to decarbonize, but that doesn't mean we want to put new systems onto vessels that are damaging the environment as well. So they are asking for the full life cycle analysis. They are looking at the full embedded carbon footprint of the systems that we are designing and bringing into the market. So, and I can only see that increasing as it's going forward, which is an excellent trend.
Thanks to both of you. Let me just go into let's say a broader perspective, because nowadays we have let's say different kind of push for a different kind of alternative fuels. Okay, not only wind propulsion, but we have something already on the market since a couple of years. That is LNG or methanol. We have a big boost of hydrogen. We have ammonia and the so-called e-fuel. So is the right moment for this, for wind propulsion?
So the big question, the $64,000 question, I guess. Well, is it the right time? The quick answer is yes. I mean, that's so. Can I can just be quiet now. No, I'll follow on. It's I'd just like to maybe reframe how people look at wind propulsion. If I was here telling you that we had a fuel available for your ship that could be 30% less carbon intensive, available today, everywhere in the world, no infrastructure investment required, and an ROI of, say, 3 years on deployment of that fuel. And you will have that. Oh, and by the way, the fuel doesn't cost anything after deployment. That, literally, I would be having people banging down the door to try to burn that fuel. But we don't burn anything. Actually, I sometimes joke, if we cut up our sails and put them into a boiler and burn them, maybe we'd get more investment. But the issue here is perspective. And when you're looking at those things available today, in primary wind, if you're designing a ship from scratch as a new build, those numbers start escalating very quickly. Way above 50% is possible. If you're operationally and remember, these numbers are delivered as a motor vessel on exactly the same operational profile on that motor vessel without the wind elements. That is not the way that actually wind can be optimized. If you're weather routing, possibly reducing speed a little bit, you're increasing the percentage of the wind energy that can be delivered to that vessel. So we do have systems and projects underway that are 60, 70, 80% of the energy to that vessel is being delivered by the wind with auxiliary engines. That starts to really, really shatter the paradigm that we're talking about now, where you have a alternative fuel delivery that could be, say, 40% across the fleet, rather than the pretty much 100% green fuel approach that we've adopted at the moment. So in that sense, it's absolutely the right time. And it also buys us some time, because we're reducing our carbon use. So our carbon budget is being extended. It buys us some time to bring in those alternative fuels that we absolutely need. Of course we do. but we have more time and we will have more carbon budget to invest in those. And that carbon budget, if we're aiming at a 1.5 degree or around 1.5 degree warming, is around about 8 years of business as usual carbon emissions. If we push that out to a 2 degree, we're probably looking at just over a decade. So by 2030, we pretty much, if we haven't made the changes by then, we go off a cliff. We have to go to zero emissions almost immediately to reach those goals. But Diane, would you like to add something to that?
Yeah, just very, very briefly, I think there are 2 points. Most of the ship owners that I'm talking to think that the alternative fuels will be 3 times more expensive. And if we can reduce the overall net demand for fuel, then we start to bring the current economic model more in line with what the net zero financial model would look like. That's the first thing. The second thing is that most of the alternative fuels are depending on primary renewable energy for their production. And that's not a useful use of the power of wind, say, to convert it into something else that we would then transport about to put into a ship when there is an abundance of free offshore energy out there that we can harness at source to provide direct thrust. And I think so why now is a good time is because we're reducing net overall demand, but also we're starting to see the ocean as a source of energy that can be deployed to move ships, rather than seeing the land as the place where that energy that was made at sea is then brought back into land, converted into another energy source, taken back out to sea. Cut out the middleman, use what we can whilst we're at sea, and the rest can come from renewable powered alternative fuels.
Thanks a lot. We have still two questions, please with short answers, because we have a number of them coming from the audience that I want to raise you on. So the first one, that I think it should be easy, is it working with each and every ship?
I'll take this. The short answer is pretty much yes. There are different systems which are applicable to different types of vessel. If you're looking at retrofit, then there are some issues around, for example, a container ship where its entire deck is covered in containers. So it's easier to deploy something like an off-deck system, maybe a kite. However, when we go back to new builds, pretty much yes. There is no restriction on what vessel, except for maybe a few very specialized vessels that could handle wind propulsion. The low-hanging fruit will be the tankers and the bulkers, because they have a lot, existing tankers and bulkers, because they have a lot of deck space for rigs to be deployed. But we're seeing systems going on virtually every type of vessel at the moment.
Thanks. And the very last one, what about wind predictability?
I'll jump in to do that one. Yeah, it's a mathematical statistical challenge, but we have the computing power and the academic prowess to make wind predictable within a percentage of a fraction of a percentage accuracy, to the point where we can work with the insurance industry to insure against the wind not blowing. So it seems like it's a risk, but the risk of predicting what a volatile commodity market is going to do is much more of a challenge than predicting what the wind will do.
Gavin, you want to add, or we move to?
Yeah, I could just very quickly add that. I mean, if you're looking at the wind predictability, you've got the macro side where we've got weather routing software. You've got the as we come into that micro side, then you've got the forecasting, and as Di is saying, you know, she's working with the European Space Agency. Or your really detailed forecasting. We've got huge amounts of data there. On the vessel itself, you'll have a weather station. On the rigs themselves, you've got sensors. There's a potential for deploying LiDAR, which is used actually on some of the very large wind turbines to actually look out from the rig and find the way the wind is coming into the rig. giving it enough time, giving it multiple seconds to actually adjust and actually optimize what it's taking in. One last thing I will say on this is the EDI specifically has one of its failings, or one of the issues around EDI is the use of the global wind matrix in there to predict the delivery of a percentage of energy that wind can deliver to the EDI calculation. That is being reassessed. We're working on a project to take a look at that, to look at route specific and even vessel specific predictions, rather than, or a matrix rather than a global wind matrix, which only I think goes up to 18 knots of wind. And we all know that the wind blows a hell of a lot harder than that out at sea.
Thanks a lot. There should be a lot of interest in this, because we have a number of questions coming from the audience. So let me go through. The first one is probably a little bit more for me, because it's a question that say, how can we name a big thing, but that is coming in 10 years time? That is the name of the webinar itself. Of course, we are talking about very innovative things, and that is already available in a way, but on a large industry perspective, it takes years to come, such as exactly as it was yesterday. We had another one on H2, on hydrogen, in the maritime domain, with shipyard, certification society, energy producers, and it was more or less the same. So the real, let's say, potential massive industry development is 10 years time. Probably hydrogen is even a bit more, because it's a bit more complex, of course, than wind propulsion in a way. So the second one is just in a nutshell, if you could tell us which are the, let's say, the three main barriers for this. You tackled a number of this already, but okay, if you have to mention three barriers to wind propulsion now, just three, without just three, but quickly.
Who's going first? The main barrier is the proof of concept funding, and that is very challenging, because obviously we've got a COVID situation overlaid on a complex commercial situation. So the regulations that are currently emerged around the shipping industry are not binding, and they're not short term around emission reduction. And so there isn't really a flow of capital to support any sort of proof of concept. And within shipping, proof of concept is very expensive, because the things are very big. Now, we've modeled our technology in computational fluid dynamics, which is a really highly accurate way of doing things, but that's not satisfactory to the market. So we can do it cost effectively, but people want to see a real life demonstrator. So the first obstacle is money. The second obstacle is time. To your point about, this is the next big thing. We have to test this technology in the real world for a year. So if we got it installed today, we'd still need to test it for a whole year before we could put it into commercializing, full commercialization. And so I think the third big obstacle is the lack of impetus from the market to try and work with innovation. And I'm not saying that as a criticism particularly. I know that all of the people that I've worked with very much want to see what we're doing happen, but none of them within their own existing business systems have the capacity to innovate. There are lots of small companies. They don't often have big R&D budgets. There has to be a way, and I know that this is being discussed with IMO and the International Chamber of Shipping, but there has to be a way to accelerate the innovation process in the maritime sector.
Okay,
Gavin?
Yeah. I'll give you, okay, so the first one is fuel price. That is a critical issue, and we are seeing a and I think that's for any innovations coming into the market, any decarbonisation innovations. So we are seeing proposals from the $2 per ton fuel levy that's being promoted by ICS and BIMCO, I believe, as an innovation fund, right the way through the EU ETS, and just recently Trafigura, the very large charterer, has just sent a proposal to the IMO for $250 to $300 per ton of CO2 levy. That's around about $750 to $1,000 per ton of fuel levy. Now, at that level, if that's ring fenced and brought back into the industry as innovation, that is huge, just as the EU ETS system is proposing. So I think fuel prices is one. The second one is information and knowledge, and that touches on the demonstrator vessels, having enough demonstrators in the water. And most companies want something like 3 reference points, so they can actually see a similar system working on 3 different vessels, so they can get security around the risk or the costs that they are looking to have. And the final one, and probably the really recalcitrant one, is perception. Perception around what wind propulsion is, perception even on many levels, but for example, perception of wind propulsion as an energy efficiency measure as opposed to a propulsion measure. And it's very much a propulsion measure. And once you accept that, the changes in the way this can be deployed, how it will be deployed, how it will be financed, start to fall in place. And frankly, that's probably the largest part of my job as the Association Secretary General, is to challenge those perceptions and pretty much lead people through the process of understanding what this could actually mean and framing that for policy.
Quite clear, thanks. The second one is, are there any references, research, studies where it is possible to, to see the energy savings costs related to wind propulsion?
Shall I take that one, Di?
You can do, yeah.
Yes, there are. And the very quick answer is, please go to our website, which is wind-ship.org. We have market projections there. There's an archive of research there. Very soon there'll also be an archive of all the media releases and articles written. We also have a project currently underway by the EU, the North Sea Interreg region, and that's deploying 5 systems, 2 already deployed, 1 will be installed this week or possibly next week. Those are being validated, tracked. All of that information will be in the reports that will be coming out, I think 2021, end of 2021, after a year of operation, just as Di was talking about. These are retrofit systems. It's not, how can I say, there are no systems currently that collect all of the systems together and validate and can compare these, but there are projects underway to do that more effectively. But the problem is, every ship in its operation will be slightly different. Every technology will be slightly different in the operational profiles, but there is a maturing in the assessment of those. There's quite a bit of research that's been done around this, but what we really need is real data from real ships, and there is some of that available. It's increasingly coming into the market.
Could I just make one small point as well? I mean, I think in the shipping industry, there are many variables that have to be measured, and we know that a ship on the same route on 2 different dates will perform with different fuel consumption metrics. One of the challenges that we noticed was that people would say to us, well, what's the one number? How much fuel will you save? And, on a windy October day, we can sail a Panamax vessel using fast rigs only. But that's not true necessarily in July when we would be motor sailing. So what we have to do is to measure all of those data points, which we've done in big computational fluid dynamic models. We've modeled the ship, and then we've modeled it with the wings and without the wings, and we've run it through big hind-class weather data systems measuring 6 journeys in each season at 10-kilometer points across the journey. So huge amounts of data that you aggregate into one number. That's what everybody wants. What's the one number? 20%. On that route, we save 20% on average a year fuel. But it's, you know, there are a lot of variables. Will wind correctly harnessed reduce your fuel bill? The answer is yes. But it will change from day to day, just as it changes from day to day on the amount of fuel you consume, depending on how fast you have to go to deliver your cargo. So I think we need to be mindful of the fact that we have to ask the same questions of the incumbent technology as we do of the new technology.
Thanks. 2 more. The first one is wind propulsion seen as viable for coastal inland shipping, where there may be less scope for weather routing, additional navigational challenges, and more air drought restrictions, or is it primarily seen as a deep sea solution?
I'm going to say a very quick word. I can see Gavin leaning forward. This is where we have a fight about who's going to say what to who. Coastal shipping, smaller vessels, the smaller the vessel, the more thrust you can get from the wind. So the less routing and optimization you can do, but inherently those vessels are smaller, and so you can get more energy from the wind. Now, Gavin.
No, you stole my thunder that time, so you paid me back.
I'm so sorry.
No, that's absolutely fine. Of course, you know, inland vessels in some areas of the world are going to be wind will be a useful component there. The coastal vessels, I mean, it depends what the routes are, etc. You know, in the North Sea region, there's a lot of short sea shipping, and probably it's easier to talk about short sea shipping because that's, you know, that's how ships are going to be operating on short routes, sometimes just on coastal routes, but sometimes out at sea as well. And there is definitely an economic argument for having wind propulsion on those vessels. What I would also say is we're talking about large vessels here. We're not talking about the 2 million plus small vessels, fishing vessels, inter-island vessels, etc., around the world. Those vessels also have really substantial opportunities to reduce their energy provision from fossil fuels and from alternative fuels using wind systems. But it's going to be catering to those vessels, designing the systems at the scale that those vessels need. And of course, you're not going to put no ship owner is going to put wind propulsion on a vessel that doesn't need it.
Next one, we in the meantime, some more came, so I think it's good to have still 5 minutes to go for short answers. So the first one is, what's your perception on the relationship between the level of the industrialization and the envisioned savings profiles?
Alexa, could you repeat that, please?
Can you give us that question again?
I think the issue is, I was literally reading, but the issue is that there is a certain level of industrialization, okay? Is that industrialization already prepared to deliver the envisaged savings, the predicted savings, or is still, the savings are still, you know, theoretical calculations? So this is the way in which I may translate the question coming from.
Yeah, okay, maybe I should take this from, as you mentioned, Alexia, from the slide earlier on this, probably going to be 13, possibly 14 installations of wind propulsion systems on vessels already by the end of this year. Now, those systems some of those systems, the companies are playing very their cards very close to their chest. There are some publicly released statistics for rotor sales, for example. Maersk Tankers has a ship with rotor sails on, 2 30-meter rotor sails on a 109,000 deadweight ton tanker, LR2 product tanker. That has a certified saving of 8.2% over a year of operation. And that's on a vessel that could take actually 4 rotors and is not optimized for wind at all. So that's pretty much putting wind on a standard tanker, or if you like, a brick with pointy bow and large engines in her. And that is operated in exactly the same way as she would be operated as a motor vessel. So if you were then to optimize that and maybe change that, then you could be getting over the 10% area by weather routing, etc. There is a VLCC with some retractable wing sails that's just been deployed in China. Those numbers I am not so sure about because they are keeping them quite quiet, but they're looking at, I've seen numbers being quoted at between the 5 and 20% mark for the 2 large wing sails. There's a second one on order in 2022. So there's another rotor sail that's been deployed on a ship called the Femme Pollux. Very large rotor on a very small vessel, got around the 20% savings from one rotor. I think she's about a 4,000, 5,000 deadweight ton general cargo vessel. So there are some statistics, but they're patchy, and unfortunately, as commercial interests are important, some of those statistics are embargoed and I can't give those easily. But yes, we are. On the industrialization side of things, I just wanted to mention a number of our members are looking, for example, to set up production lines in China. One of them is already investing in that. So we're going to be seeing the rollout of these systems on a much larger scale as we go forward. And the pipeline, as we said before, is very robust, but those are coming in as first units or demonstrator units initially, but we will see that commercialization scaling up just as we've seen in all other industries.
There is just one point also, yeah, there is a very strong message that nobody in the shipping industry wants to be the first mover. They want to be the third or the fourth.
That's always the issue of the first mover, right? For such kind
so we have to get over that, and that means that we need to find some way of having a global political support for those organizations, those companies that do want to be first mover, because they can see the benefits of it. And as we get to a more kind of industrialized solution, then the unit cost per wing or rotor will drop. So it's in everybody's interest that we figure out how to get over the innovation hump to bring this technology to market as quickly as possible. On mute.
Alexia, I can't hear you. You're on mute.
Sorry, my fault. Are naval engineer prepared for designing with propulsion vessels?
Well, the simple answer to that is yes. Yeah. The creativity at the moment is incredible. I mean, we have in the association we have over 130 members from some very large shipping companies and class to over 40 technology providers and projects as well. And the naval architects are incredible. They're coming up with some incredible designs. The engineers are taking a look at this and say, absolutely, these are doable. There is no, I would say, it's a very broad statement, but there is no technical or engineering barrier at all to the deployment of these. It's solely now a financial issue. And as Di rightly said, also the policy or political support behind true decarbonisation of shipping very quickly we can deliver these systems into the market. That is what's required. So I would say, yep, engineering, naval architects, no, they're absolutely delighted to be working on these projects, and increasingly are doing so.
And I would like to endorse that position and say that we work with naval architects looking at the aerodynamics of the wings that come out of racing, but they're pragmatic designers. But we also work with marine engineers from Malin on the Clyde, and they are deploying the sort of technology that we're suggesting, so the footings, the steel footings that our wings will sit on, are exactly the same that they use to put cranes on vessels that are going out to support oil and gas. So we're using proven technology, but just in different ways. The engineering, as I keep telling them, is the easy bit.
Thanks. The very last one is probably for you, Diane, but I absolutely tell you that is true. It's coming from the audience, meaning that if I have some money, is there any place where I can go for, you know, supporting someone, crowdfunding or investors, or where can I go?
You can come here. We welcome you with open arms. I mean, seriously, we are poised to. We've got a good to go project, which people call shovel ready, but I don't think that's the right analogy for what we're doing. But we're ready to go. The project team's in place. We've done the technology research, we've done the meteorological research, and we've done the financial modelling. So I think there is, you know, a real demonstration that the market is just on the cusp of success now. And I, as some people know, have a background in Formula One, so I really think that the benefit of competition is valuable, because if we put our wing sails on the water, then I guess my best hope is that someone could come along and say, well, we can do better than that, and they would increase the percentage of the fuel savings. And so as a citizen of the world, that benefits our challenge with addressing a climate emergency. So competition is good, but you know, in the first instance, we'll take your money.
I should probably draw that back from you know, Di will be asking for the phone number of the person. But, yeah, I mean,
we cannot. There is the GDPR. For the GDPR.
Yeah, fair enough. Fair enough. Yeah, there are some absolutely fascinating projects. You know, if I had more money and more time, I could spend my whole life going around these projects, investing in them, working with them as well. I mean, this is the amazing thing about our community is, I would like to send this message out a little bit, is I've been really impressed by our members. Not putting aside the competitive nature of the industry at all, but working together to develop this market and these systems, and increasingly collaborating on these. And as Di's project shows, multi-stakeholder collaboration, just really exciting rethinking of how we're deploying you know, a technology that's been around for centuries or millennia, but it's been brought into the 21st century. And we had a couple of years ago, we had a conference where came out at the end of it of making shipping sexy again. This technology and a lot of the other technologies out there, but this technology is one of those technologies that just gets people really excited. And if you're a naval architect or you're an investor coming into the sector, wow, it's just a fantastic time to get involved in a very old business that hasn't seen dramatic change over the last, you know, 50 years, is going through an incredible transition and transformation, and wind propulsion is right on the cutting edge of that.
Thanks.
So you can give me the money, don't give it to Di.
Thanks, really. Thanks, Gavin. Thanks, Diane. It was great, and it was really great. And you see the interest that we raised. If we got some, we're going to have some question more. We are going to send it to you. Thanks for joining us today. It was really great. Thanks for the audience that was actively participating. Thanks to the team, Gloria and Marika. And please stay tuned because we have still a couple of events tomorrow about digitalization, interoperability in the rail sector, and one about the creation of the network of excellence of ports look into the future, the Docks the Future network of excellence. So stay tuned even tomorrow. Thanks for that. Have a good day and fair wind, I may say.
Thank you.
To you all. Thank you.
Thank you
Bye
very
bye.
much. Thank you, Circle. Bye bye.
Bye bye.